All right, let's talk about horizontal asymptotes of rational functions. We've talked about vertical asymptotes. We've talked about holes or removable discontinuity, and those are a little bit more straightforward. In this instance, when we talk about horizontal asymptotes, we have three different cases to look at, okay? And they all have to do with the degree of the numerator and the denominator. So who has the highest exponent, the numerator or denominator? So if you have a function that is what I like to call top-heavy, that means the degree of the numerator is larger, then there is no horizontal asymptote. In case 2, if you look at a function that I like to call bottom-heavy, that means the degree of your denominator is larger, okay? In that case, you have a horizontal asymptote of y equals 0, okay? So if you have a higher degree or a larger power in the denominator, there's a horizontal asymptote at y equals 0. So let's look at those first two, okay? So in this numerator, I have an exponent of 2, and in the denominator, my degree is only a 1. That's why there's no horizontal asymptote, because this is top-heavy, all right? In the second example, the degree of your numerator is a 1, and the degree of your denominator is a 2. So because there is a higher exponent, a higher degree in my denominator, the horizontal asymptote is y equals 0. And then this very last one right here is what I like to call balanced. That's when the degree of my numerator and denominator are the same. So this is to the second power and this is to the second power. So when that happens, what we're going to do is write our equation using the ratio of the leading coefficients, the numbers that are in front of your variables with the highest degree. So let's look at this one right here. So I can see that I have an x squared term in my numerator and a 3x squared in my denominator. So their exponents are the same. Now the coefficient, the leading coefficient of the numerator is a 1, and in the denominator, it's a 3. So what is that ratio? It's 1 over 3. So the horizontal asymptote is the equation y equals 1/3. Okay? So just to recap, if you are top-heavy function, no horizontal asymptote. Bottom-heavy function, y equals 0. If you are a balanced function where your degrees are the same, then you use the ratio of your leading coefficients and you write the equation y equals 1/3. So let's look at a couple and let's just identify. We're going to state if the degree of the numerator is greater than, less than, or equal to the degree of the denominator. And then we're going to write the equation of the horizontal asymptote where appropriate. Okay, so you might want to maybe pause the video and see if you can figure these out by yourself. And then come back and check. All right, let's look at this first function right here. I can see that the degree of my numerator and denominator are the same. So we're going to use the ratio of the leading coefficients, right? This is a 3 and this is a 1. So this horizontal asymptote is located at y equals 3 over 1. Or just y equals 3. All right, let's look at this next one. I can see that the degree of the numerator is 1 and the denominator exponent is a 2. So we're bottom heavy. Okay, so for this problem, we have a horizontal asymptote at y equals 0. Okay, let's look at this example right here. The degree of our numerator is greater than the degree of our denominator. Because that exponent up here in our numerator is larger, that's top heavy, that means we do not have a horizontal asymptote. No horizontal asymptote. Okay? The same is true for this next function right here. The degree of the numerator is greater than the degree of the denominator. So because that's the case, again, there's no horizontal asymptote. All right? Let's look at a couple more. Let's look at, this one right here. If I have y equals x squared, so my exponent in the degree in my numerator is a squared, and the degree in my denominator is a squared, that means it's a balanced equation, okay? So we're going to use the ratio of our leading coefficients. This is a 1, and this leading coefficient in my denominator is a -2. So this horizontal asymptote is just y equals a -1/2. Okay? So hopefully that makes sense to you guys. Those are just some quick examples. Let's see. Let's go through and look at this function is another balanced equation because our exponents are the same. Our degrees are the same. So this would be a horizontal asymptote of y equals 8/4, which we would definitely simplify. What is 8 divided by 4? That's just 2. That might be the last one on these notes. Oh, here's one. So we have a balanced equation here. Again, our leading coefficients are a -3 and a +2. So this horizontal asymptote is just y equals -3/2. Okay, so now let's look at our remaining equations. Remember, if we're bottom heavy, our horizontal asymptote is y equals 0. So if I zoom in on this function right here, the degree of our denominator is larger. So this horizontal asymptote is just y equals 0. But right next to it, we have a function whose degree in the numerator is larger. So remember, if the degree of the numerator is larger, that horizontal asymptote is just none. There's not one. Now, some people might want to be tempted to write 0 there, and that can be a little misleading. We don't want somebody to think that the equation is y equals 0 and maybe you left off the y value or something. Don't write the number 0, just put none. There is not a horizontal asymptote. And then, of course, down here in this bottom row, we have two functions who have degrees that are larger in the denominator, which means both of these have horizontal asymptotes at y equals 0. And of course, the more you practice this, the faster you're going to see them. Now, very quickly, it's not on your note sheet, but I did want to put it all together, okay? So let's look at this equation. First things first, it is in standard form. So which degree is larger, the numerator or the denominator? And hopefully you see that the denominator is larger, which tells us we have a horizontal asymptote at y equals 0. Actually, let me write it over here. We have a horizontal asymptote at y equals 0. Now, to check for holes in vertical asymptotes, you need to factor your function. So I am going to actually scoot this over. So if I factor my numerator, let's look what that gives us. 2x times x. If we have a 15 and we need to make a 7, let's put a 5 there and a 3 there. So that would be a positive 10x minus 3x would give us a 7x, yes. And then in our denominator, we would factor out an x variable here and leave us with x squared minus 25. So we have a GCF of x that we would not need to factor out. And then this right here is the difference of two perfect squares, x squared minus 25. So that would be x plus 5 times x minus 5. Okay, so we found the horizontal asymptote when we were in standard form. Now let's look for a hole in the graph. And I see that both the numerator and the denominator have the factor of x equals positive 5. So if I want to look for a hole in my graph, I just set that common factor equal to 0 and solve, right? So we subtract 5 from both sides and we get x equals -5. That's where we have a hole in the graph. Now, where are we going to have a vertical asymptote? Well, that occurs when you set any remaining factor in your denominator and only in your denominator equal to 0. So I have a factor here and I have a factor here. So I set my first factor, x equal to 0, and solve, but that's already solved. So I have a vertical asymptote there. And then I have another one at x minus 5 equals 0. So I set that factor equal to 0 and solve. And then I can just add 5 to both sides of my equation. And that just gives me x equals positive 5. So this graph actually has two vertical asymptotes, one hole in the graph, and a horizontal asymptote of y equals 0.